All right. Logical operations. And the goal of logical operations is to what? That we have given set of propositions and we want to construct more propositions. Okay. So, for example, I have a proposition which says it is raining, and I have a proposition which says that it is cold. It is raining and it is cold is another proposition. Okay, and we say that this is a compound proposition because it is compound of two other propositions. Okay, what determines the truth value of this compound proposition? So there are a set of rules which define what is the truth value of the compound proposition based on the truth value of the original propositions. Okay, so what that says is that if you know the truth value of the original statements, you must be able to figure out the truth value of the compound proposition. Okay, are you with me?
Yes.
Okay, cool. Let's see some basic rules, and here are the rules for the AND. AND को हम formally conjunction operator कहते हैं. Okay, so it's a conjunction operator. We are conjuncting two different propositions. Okay, we'll denote propositions with we'll use some algebra. Okay, so we'll use one proposition name as P, and the other proposition would be denoted by Q, and the conjunction of P and Q would be denoted by P and Q. This thing is called logical AND. लेटेक में लिखना हो तो this is wedge, and you read this as P and Q. Okay, and this is their truth table. Okay, this tells you that if both P and Q are true, then P and Q is definitely true. Okay, in all other cases P and Q is false. Okay, so for P and Q to be true, you need both P to be true and Q to be true. Okay, I'm using the word and multiple times. Anyhow, so if you have statement P which says that it is sunny, and your statement Q which says that I go to the beach, P and Q says that it is sunny and I'm going to the beach or something like that. Okay, awesome. Are we good? Questions? Cool. We logically have a disjunctive operator as well, or the OR operator. So an OR operator is true when either of P and Q is true. Okay, if P is true or Q is true, then P or Q is true. Okay, you invert the AND operator to get the logical OR operator, and here's an example. If P represents I found a unicorn and Q represents I won the lottery, then P or Q says that either I found a unicorn or I won the lottery. Okay, are we good? Okay, moving on. The third operator that we are going to use is called the exclusive OR. Exclusive OR, in my view, is actually what we usually mean by OR in daily life. Okay, we'll see the example in a moment. So exclusive OR says that, well, the inversion of exclusive. No, scratch what I just said. Okay, but I have something similar to say in a moment. Okay, all right. So exclusive OR is true when the original two statements have different truth values. Okay. So if both of them are either true or both of them are either false, then exclusive OR will be false. Okay, we don't want both of them to have the same truth value. Okay, so if one of them is true and the other one is false, then you will have a true for the exclusive OR statement. Okay, so we read it simply as P exclusive OR Q, and here's an example. If P represents I am in mood for pizza and Q represents that I am in mood for sushi, then P exclusive OR Q represents this: either I am in mood for pizza or sushi, but not both. Okay, and that's, if you look at this example, if you were to say this in common language, you would not say the last part. The last part would be implied by your conversation. Okay, when I say that, okay, I'm gonna go for a pizza or sushi, then it's implied in the language that I'm not gonna go for both. Okay, But the way we are defining the logic, we are scratching that possibility explicitly by using exclusive OR. Okay? यहाँ पे अगर मैंने simply OR use किया होता, तो that would have allowed me to go for both of them. Okay? So keep that in mind. That's the difference between our common tongue and what we write in logic. Okay? So if I ask you on exam to write a statement for this part, okay? I'm in mood for pizza or sushi. You would write P or Q, okay? But that allows the possibility that both P and Q are true. Okay? Are we on the same page? That actually confuses people, because at this point we are kind of diverging from the kind of normal meaning of OR. Okay, this OR is different from the OR that we use in the normal tongue. All right. The fourth operator is the negation operator. We read it as not. Okay, this is kind of 270-degree rotated L. Okay, so yeah, 270-degree rotated L clockwise. So negation means that you would just take the opposite of the statement. Okay, if the statement is true, the negation would be false. If the statement is false, the negation would be true. Okay. So for example, if P represents that it is weekday, not P represents that it's not weekday, it's weekend. Okay. All right. So we saw 4 operators so far. Okay. And, or, exclusive OR, and not. Okay. And I assume that you would be able to construct these truth tables. Okay. Have you constructed these truth tables in high school before? You have? Okay. Okay. Nice. Cool. Okay. Then it's gonna be a breeze for you.